And my sincere thanks to you and the director, Dr. Dixit, and other eminent personalities who chaired the session, and also the other colleagues. Uh, Nowadays, the nanomaterials are gaining importance to create an environment which is more sustainable and also pollution free. So we have great challenges in the years when we are using materials. Some hazardous materials also are coming in and which are harmful to nature. And in that aspect, nanomaterials also having its own drawbacks. And nano materials are also not free from hazardous aspect, and in that aspect we can devise new nanomaterials which can save our environment, and also which can make our environment to be a sustainable one in terms of energy, and also the pollution energy fulfilled and the pollution free world. So with this I start my talk. uh, So now I will give you a brief introduction. Then I will concentrate how for the wastewater treatment we can use nanomaterials, and for energy storage applications, especially for supercapacitors, how can we use nanoparticles, and how we can devise and apply nano sensors for different applications, and some more aspects in terms of renewable energy, which will also I will share, and also I will share some of the ideas and the biofuels, how the nano catalysts or nano composites have been used, and with that I will be concluding. So nanomaterials are materials with structural components smaller than 100 nanometers. Due to their size, they exhibit unique properties such as enhancement, reactivity, mechanical strength, and electrical conductivity. So this is a general flow chart or diagram how the nano materials can play a vital role in different fields. For example, we are having energy conversion on the fuel cells, solar cells, and triboelectric generators, TNG triboelectric generators, and energy storage, supercapacitors, and superconductivity, and nano lubricants, and the nano refrigerants, and insulating materials for energy transmission. Also we can make more efficient the transmission by using nano insulators. So these are the some of the aspects of wide areas which we are going to cover. And just we highlighted some of the chart to how the nanoparticles can be grown, or nanocrystals can be grown, and the nanocomposites can be developed by two diagrams. Let us start with wastewater treatment. We are having the industrial wastages, human wastages, and wastages occurring due to the climate change, and so on. So, industrial wastages, we are having many type of industrial wastages in the form of solid waste, as well as liquid waste, as well as gaseous wastages, and human activities occurring due to human usage of food, or using fertilizer or pesticides, or and so on. And the climate change is also occurring, and which will add the climate change is a major effect which is occurring because of this kind of pollution, and which in turn it affects the earth environment. So when the environment gets affected, uh, again it changes the climate change. So it's a cyclic process. So in this case, we are in need of purify the water. And the famous English poet Eliot told sometimes back, water, water everywhere, but there is no even a single drop to drink. So even we are having countries in Africa and other some of the continents where we are having uh, water scarcity. We are having a plenty of water. More than 80% of the water in the earth is in the form of seawater. But a lot of water, river water, is also getting polluted and wasted and mixed with the sea. And we are in need of purifying the water. And the nanomaterial will play a major role in purifying the water. So in this aspect, we can have there are different treatments that we can take the polluted wastewater and applying the nanotechnology based water treatment. Then we can apply membrane technology on one side, and on the other side we can use the absorption technology. And in both cases we can achieve the purified water. Uh, Even drinkable water. So carbon nanotube membrane, graphene membrane, cellulose membrane are the famous membrane techniques which have been used under the membrane technology. While the absorption technology, we are having biometallic absorption, metal absorption, mixed oxide absorption, and they are employed in absorption technology. So the dye industry is also having a major role in polluting the water, and this wastewater from the dye industry can be used to pass through the array of nano composites, and then we can either use membrane technology or the absorption technology, depending on the contents or the chemicals constituents of this polluted water. And we can select, according to that we can select suitable technology, and we can have a different types of approaches in during the treatment of the water. And bioelectrochemical system can be used, and advanced oxidation process together, which can membrane separation, photocatalytic degradation, microbial degradation are the various steps which you have to follow through during the time of treatment. And next, I am talking about the supercapacitors. We are having energy storage devices that offer higher power density than traditional batteries and faster charging times. The supercapacitors are coming into reality only because of the advancement in nanomaterials. So they rely on materials with large surface areas to store energy via electrostatic charges. I can boldly say that if there is no nanomaterial, then there is no supercapacitors. Only because of the nanomaterials or nanocomposites, we are able to achieve many things in the energy field in the form of supercapacitors. Graphene, carbon nanotubes, and metal oxides are commonly used for their high surface area and excellent conductivity. Acoustic energy enhances the force structure of electrode materials, improving ion transport and charge storage efficiency. The supercapacitors electrode material, we are having a different types of materials which we can select for different applications. So we can have this one in electric double layer supercapacitors, in pseudo capacitors, and the other one type of capacitors. So the in electric double layer capacitors, can remove this. It's super. It's uh, Oh, in electric double layer capacitors, we are having carbon nanomaterials, activated form of carbon, carbon in aerogel form. In pseudo capacitors, we have metal and their oxides, conducting polymer and their composites. In hybrid supercapacitors, we are having metal, their oxides, and CNMS as composites. This is an overview how the supercapacitors plays a major role. One side we are having anode and the other side we are having cathode. In between we are having a separator and we are having a metal salt organic linker and which performs hydrothermal operation we perform and we are getting a metal oxide frameworks. Then calcination can be done and by which we can form metal sulfide, carbon materials, metal oxide, and so on. And finally, which will lead to the supercapacitors. So the nanomaterials in solar cells, the principle is photovoltaic cells, they rely on materials and they can convert the sunlight into electricity efficiently. Sonication is also used sometimes in the synthesis of quantum dots and metal oxide nanoparticles, ensuring a controlled size distribution that maximizes light absorption, which cannot be observed, which cannot be obtained without sonication. Acoustic waves also play a major role. They help in uniformly dispersing the nanoparticles in solar cell films, improving charge separation and electron transport. Sensors, we are having, I have given you an overall view. The sensors are devices or components that detect and respond to changes in their environment. Sensors convert physical quantities like temperature, pressure, light, or motion into electrical signals that can be measured and analyzed. Here, 0D, 1D, 2D, and 3D nanomaterials we have classified and given the diagrams and from each category we can form nano sensors. So these type of nano sensors, they are based on the working principle and the parameter of size and larger surface area. When the size varies, the performance of the nano sensor varies. So we can have nano sensors even at 2 nanometers, or we can have the nano sensors even at 20 nanometers. But the size plays a major role in the performance of the nano sensors, and depending on the application, we can select a suitable or we can devise a suitable nano sensors for which we need a suitable size material size, suitable nano size. Here, these biosensors, we are having different types, starting from tendrines, graphene, nanowires, polymeric nanoparticles, chitosan, fullerene, nanoparticles, quantum dots, and finally carbon nanotubes. And the biosensors, we have the different types of steps which have to be followed. Water quality identification, management and mapping, and then toxin detection in environment, lab and factory. Environments monitoring and mapping, drug discovery, food quality assurance and management, prosthetic devices, soil management, detection of infectious disease. So the future of the world, both industrial and medical world, will depend on these bio nano sensors. There is no doubt in it. Already they are playing a major role. Still, many more achievements are in the room, which will be explored in the coming years. So the biosensors, we are having a bioelement transducer coupled together. So one hand we have the analyte, the another hand we can have the product. So the signal will be amplified, and then we can use a suitable processor and display signal, and using the suitable control system, which comprises of sensing unit, controller, activating unit, we can obtain the desired output. So these bio nano sensors are the one of the hottest topics in the scientific world now. So green synthesis of the nanoparticles becomes the need of the hour because of when we use chemicals, uh, uh, again the environment gets polluted. So in order to save the environment and also to remove to be free from the hazardous materials, it is essential to use green synthesis of nano materials or nanocomposites. Green synthesis is also helpful in many ways. Not only pollution free, it creates pollution free environment, but it also used for medical applications. So India is a country which is rich in many medical plants, which is famous for many medical flowers, many medical roots, many medical stems, many medical leaves, and so on. So when we adopt the green synthesis of nanoparticles, uh, we, we can select suitable leaves or suitable flowers or suitable roots and synthesis nano material. We did not obtain not only the pollution free environment but also they are medicinally useful. So the plant extract combined to the metal solution, color changes when the solution is stirred, color changes indicate the presence of the nanoparticles. So the steps, different steps I have given in the slide which you can go through. So these are the various steps involved in the green synthesis of nanoparticles, and the perfection can be achieved for the size and the surface area of the nanoparticles only by trial and error. So these are the different methods and applications which can be adopted during the green synthesis in nanoparticles. So if you take the green synthesis nanoparticles, we have the various steps starting from photocatalysis, genetic transformation, nanobiosensors, pollution monitoring, nanopesticides, agricultural diagnostics, soil enhancement, precision farming, plant development. So all these things can be can be achieved by means of these green synthesis nanoparticles. On the other hand, the metallic nanoparticles, we have two approaches, top-down approach and bottom-up approach. So the top-down approach, we have the chemicals etching, laser ablation or laser infusion, mechanical milling or ball milling, sputtering, electro explosion. And the bottom-up approach, we are having chemical vapor deposition, salt gel processes, laser pyrolysis, spray pyrolysis, atomic or molecular condensation, aerosol processes. So finally, and we have the green synthesis in the bottom-up approach. So this bottom-up approach adopted with through the green synthesis method, we have the plant technology, we have the leaves, root, flower, fruit, and also stem. Perhaps I left here can be added. And the microorganism, they can be, we can treat them for bacteria, we can treat them for fungus and algae for the applications. So the CEO2 nanoparticles we have taken and we have done some study, and they have manifold applications in the fields of energy catalysis, imaging, medicine, sensing, and electronics. Nanomaterials are efficiently used in battery technology, especially in lithium ion batteries. The most common type of battery used in electronics and electric vehicles and energy storage systems, and nowadays they are very famous. Very latest topic of research all over the world is lithium ion batteries. So, nanomaterials such as silicon nanoparticles, graphene, and metal oxides are used to enhance battery performance, particularly in electrodes. So nanoparticle dispersion, acoustic waves again can be used to ensure uniform dispersion of nanoparticles, preventing aggregation, which improves battery capacity and stability. The enhanced surface area of nanoparticles synthesized using acoustic methods increases ion diffusion rates, improving charge or discharge cycles. The acoustic assisted electrode materials lead to higher energy density, faster charging times, and a longer battery life. If we see the diagram, we can have an idea about how the charge and discharge process takes place. For example, we are having the separator in between the anode and cathode. The aluminum current collector is used as a cathode, and copper current collector is used as an anode. And the process is the electron gets diffused. We have the lithium metal oxides, lithium ion, lithium metal carbon, and they form the operation during the discharge. So the same time for the charging, we have the separator, electrolyte, which plays a major role. We can have different types of electrodes, and we can have different types of materials for anode and cathode also, so that we can study the performance and we can find the best performing lithium ion battery by varying these three parameters, that is electrolyte, anode and cathode. So there are a lot of rooms for research still, and still lithium ion battery goes on improvement day by day. Especially Japanese are very much involved in this area of research nowadays. The recent trends, applications, we have this acoustic energy harvesting also possible. So piezoelectric devices can be used for ongoing advancements to capture energy from vibrations and ambient sound. Recent innovations focus on making these materials more efficient, flexible, and scalable for use in urban infrastructure and personal devices. Triboelectric nanogenerators, TENGs. New developments are coming in room to enable the energy capture from sound waves in real world conditions. The research focuses on increasing power output and integrating TNGs into everyday structures for low power energy needs. I will explain the principle of triboelectric nanogenerators. So they are devices that convert mechanical energy into electrical energy using the triboelectric effect and electrostatic induction. It provides renewable, sustainable energy solutions. That's more important. It is having enormous potential to power even small devices, sensors, and wearable technologies. So we get in future we can have a nano batteries, and this for these nano batteries, this will be the leading pathway. The triboelectric nano generators will be the leading pathway for the future nano batteries. So how it works? When two materials are in contact, electrons move between them. Upon separation, they hold opposite charges, creating an electric potential. So this potential passes from one layer to the another material, and we have the flow of the current. The working principle. We have the following steps. The contact between two different materials has to be maintained at a particular level. Electron transfer during separation has to be monitored. The electrostatic induction generates an electric current because of this process. So the continuous process, the repeated contact and the separation cycles generate continuous electricity because of this continuous process. So it's a more sustainable. So the triboelectric nanogenerators will lead to a sustainable energy world and hence to a sustainable environment. So acoustics also play a major role in the energy storage. So acoustic diagnostics for batteries. We would have been heard many kind of diagnostics. So we are having acoustic diagnostics. So acoustic sensing is being applied to monitor battery health, predict failures, and extend battery life, particularly for electric vehicles and large energy storage. So this is of great importance because each time we cannot open the battery, and there are conditions in which we cannot measure the efficiency of the battery by other technical instruments, in which acoustic diagnostics play a major role. So the recent advancements include real-time monitoring of lithium ion and solid state batteries. In the industry, in the on the run, when it is flowing, we will be having the lithium ion and solid state batteries in the operation. During the operation itself, we want to test the efficiency and energy storage conditions and so on. The acoustics is the best tool to monitor the real-time process of the lithium ion and solid state batteries. The energy storage material handling. So acoustic levitation is gaining traction in the manipulation and handling of materials for energy storage applications, offering non-contact methods that improve material purity and efficiency. Because when you are talking about the nano material or nano world, the purity and efficiency are the two more important parameters. So by any other mechanical methods or chemical methods, the purity or the efficiency of the nanomaterial may be affected during the checking or the monitoring. So in that way, this method is more applicable or more suitable. The soundless nanotechnology for sound energy. So we have wind turbine optimization, wave and ocean energy. If you go to countries like Norway and Sweden, they are almost all the ocean areas they covered with various types of windmills and they placed. And not only that, they have the efficient technology to use the wave energy and ocean energy in the form of tidal energy. So nowadays they have a lot of pollution, that is noise pollution from the sea, and because of that wind turbine operations, and hence the living animals in the sea gets affected. Fish or mammals gets affected, and people are so kind to take care of the well-being of the even the sea animals in in those countries. So they want to have energy. At the same time, they want to have the soundless energy. So this soundless energy is possible only because of nanotechnology and nanomaterials. So we have they are devising new plates and new nanofibers made up of nanocomposites, which will not produce much sound during its operation. And they are trying to use it so that not only the animals or mammals in the sea did not get much affected, but at the same time, the people who are traveling the ship or the people who are swimming in the ocean will not be affected because of this noise pollution in the sea. Of course, the noise pollution in the sea at one time or another time it reaches the earth also, in the land also, and affects the seashore buildings and other buildings. So, which will the people they create the noise pollution is a great pollution, and they use this soundless nanotechnology for sound energy, which relies on the nanomaterials and nanocomposites and nanofibers. Just I put how the can be implemented and various techniques to measure the noise pollution before yeah, the introduction of nanofibers or nanocomposites, and after the introduction of nanocomposites or nanofibers into the wind turbines. The nanocomposite for sustainable biofuel or biodiesel. So nowadays in India or in developing countries, we used to call cultivate the land for food. But in Europe and US, they are having a proverb, cultivate their land for fuels. So they try to produce biofuels or biodiesels, land for fuel. They call it as land for fuel. And these biofuels or biodiesels, they can produced from in natural way as well as from artificial ways. In natural ways, they can produce, they can be produced from natural plants, natural flowers like sunflower and so on, and we can obtain biodiesels or biofuels. There are some plants specifically for this purpose, and in artificial ways. the waste cooking oil. So, of course, in all over the world, we use oils for cooking. So, the cooking oil one time, two times, after that, it becomes poisonous. So, but this poisonous oil need not be thrown out. So, they can be converted into biodiesel or biofuel. So, that oil which is going to make the land as a polluted one, if we throw out, but that same oil we can convert into biodiesel or biofuel, and we can save the environment, and we can uh, get energy from that. So biofuel is renewable, environmental friendly, and non-toxic in nature. The waste vegetable oil, artificial way, the oil is described as a renewable fuel as it does not emit any extra carbon dioxide gas to the atmosphere as opposed to fossil fuels which pollutes the atmosphere. So this aspect is very much essential to create a sustainable environment. So here the nano catalysts or nano particles, they play a major role. So a lot of research is going on in many institutes like Max Planck and so on. So how to make the environment as a clean environment by using these biofuels in the regular day-to-day life. So there, people are more conscious nowadays about the climate change and global warming because one day or other we will be affected. Even now we are affected because of this environmental change, climate change, and so on. So these are all occurring because of the environmental pollution. So we need to take care of our environment. Then only the environment will take care of us. So this aspect, this is a if you continue with the fossil fuels for a long time, definitely it will have its own impact on earth and environment, and it will have its own due course of time on us. For example, we can see many hazardous effects all over the world, sudden heavy rains, heavy floods, heavy cyclones, and so on. See, these are all effects of this kind of environmental pollution. So we are going to have the algal growth and culture and harvest, then lipid extraction, hydrothermal liquefaction, and then we have the test engine for this. Uh, Before that, from the hydrothermal liquefaction, we have the chlorella emulsional oil (CEO), conventional transesterification (CEME), and we have glycerin separation by means of test engine, and finally we can have the potential alternative fuel. So these are the different steps which have been followed. So, yes, just I put a flow chart so that you can easily, people can easily understand what's happening in the biofuel industry. So, different types of feedstock and both natural and artificial. Artificial, all waste things can be used. So, the natural, we can grow different types of plants or fruits which are rich in biofuel, and we can use these things to create the basic basic forms of the feedstock. The different types of feedstock, sunflower is used in some countries. In some countries where we are having dark, we call them as dark countries like Norway or Sweden, Finland or Iceland. So where people they don't have much of sunlight, they have some other specific crops which can grow without sunlight, and they very much depend on this waste cooking oil. There are countries they buy million tons of waste cooking oil. There are countries, the world, which they just buy tons, million tons of waste cooking oil. And they recycle and convert into the useful biofuel or biodiesel. So the feedstock is very much fundamental, and as well as we have to be very careful in selecting a suitable feedstock if you want to get a good product. So, which feedstock will give more efficient biofuel or biodiesel? We have to study. We have to study. So we have this seed extraction, and this seed extraction we have. We have this seed extraction from which we are having oil extraction and pre-treatment process. And we have the following methods: anaerobic digestion and fermentation and hydrolysis, transesterification and enzyme catalysis, from which we have we have anaerobic digestion and fermentation and hydrolysis, transesterification and enzyme catalysis. We have biomethane and biohydrogen. We have bioethanol and biomethanol, biodiesel. So these three products we can obtain, and depending on the feedstock, we can obtain the quantity, the quality of the the products will be varying. Generally, they are, all of them are known as biofuels. Of course, they are having their own different applications. For example, biomethane and biohydrocarbon is having used in the refinery industries. Bioethanol and biomethanol is having its own use in some other energy industries. Biodiesel has been used for vehicles and automation industries. So depending on the industry type, we can use the bioproducts. So I told you already that this bio waste, we are going to this waste products and be converted into biofuels. This is a wonderful picture which shows various types of waste products which are available in the earth, which we can convert into biofuels. So, kitchen waste, baggage, husk, pork, manure, corn waste, foliage, and using the pyrolysis method, we can get a biochar from that. Like coal char, we can get a biochar, and from biochar, by means of this operation, we get a nano biochar. So this nano biochar can be delivered and directly to the industry, and can be modified to use the different materials like PB, HG, CX, CD, and so on, using the metal absorption methods. And nanobiochar can be used to produce nanocatalysts, and nanobiochar can be used to produce nanosensors, and they can be produced to maintain improved soil health and plant growth, and they can be used to an alternative fertilizer. And this improved soil health and plant growth, of course, which will produce enhanced soil microbiota, and which will use to give degradation in the toxic compounds in the soil. So biodiesel is considered as an alternative fuel which can replace the traditional fuels easily with its less hazardous effects and economical pricing. And initially, there was a huge cry that the biodiesel is a little bit costly at the time of invention. But after some time, the biodiesel becomes more economical than the conventional fuels. And apart from this environmental friendly nature, but there are some problems in the efficiency of the biodiesel when compared with the conventional diesel or conventional fuels. So there lies the challenge of the biodiesel or biofuel industry. So for which we have the gift from the nano world, that is nano diesel, sorry, nano composites, nano catalysts, which have been effectively used uh, to increase the efficiency of the biodiesel. Nowadays, the increasing the efficiency of the biodiesel is not a challenge, so but it becomes a greater possibility because of this nano catalyst. So there are different types of nano catalysts have been used all over the world, and still researches are going on. So each day we are getting more and more good news from the nano catalyst world. This nano catalyst is good for this kind of efficiency and so on. So each day research article is coming by studying by highlighting the efficiency of by usage of the nano catalyst for to increase the efficiency of biofuels or biodiesels. So here I highlighted the processes how they have been taking place. So starting from the existing technology, I start. So existing technology produce CO2 and it goes to the renewable resource. And on the other hand, we get from sun energy. And in turn, we get graph refining, but the graph refining, because of the biodiesel, we get the biodiesel production, food products. So the biodiesel production leads to renewable fuel and glycerin production once again. So this is, of course, is a cyclic process. So one stage depends on the other stage, and it goes on a endless journey. So here I have given the experimental setup, actually which we have also used this setup to produce biodiesel and to study the biodiesel efficiency in our laboratory. So we can have different types of stages, different stages in which the biodiesel can be processed or biofuel can be obtained. So from water, acetic acid, vegetable oils or fats have been taken as the resource. Then we have the subcritical acetic acid added at 300 degrees centigrade with at 20 megapascal pressure. Then we get the oil base from which we are having methanol, subcritical methanol, and then we are having the purification process, and from the water base leads to triacetylene, and the purification here leads to the fumes, and which contribute to the biodiesel fuel. So these are the some of the experimental observations which we have done, and we have sometimes used acoustical techniques also to obtain the purified biodiesel, which is having more efficiency. So these diagrams will show how the efficiency have been increased by using the nano catalyst as well as the non-conventional techniques like acoustics or laser techniques. So we have used both acoustics and laser techniques also to increase the efficiency of the biodiesel or biofuel. some of the biodiesel products we obtained using the copper oxide nanoparticles. We have highlighted the copper oxide nanoparticles which we have obtained, and some of the diagrams gives a clear idea about how the biodiesel form from SO4 and the fatty acid composition of SO4. So we can see here this diagram. The low composition time varies. The time is an important factor. So as the time increases, we are having the huge peaks, and which gives the more refinery aspect of the biodiesel and biofuel. So the time factor is also playing a major role in increasing the product, the efficiency of the biodiesel or the biofuel. So the compound name, just I have given the compound name which you have been obtained through our studies. So 7 as no for me, FFA is 7.07%. 2 pentanetryl 18.89%, 9,12 acetonic acid 74.04%. Totally we are having 100. This is the profile of SO4. These are of course more technical details which you can refer to at a later stage also. And the fame composition, here we are having the properties. Um, the frame composition of SO4. So the volume yield is given by this equation, volume of the product divided by volume of the oil into 100. So most abundant fame, 9 octodisonic acid methyl ester, 54.29%. Other fame components, 28.54. Total fame conversion is 82.83. So others just 17.17%. So just as a conclusion, so the rapid developments in nanotechnology offer a wide range of possibilities for innovation in different fields. Nanotechnology has the potential to revolutionize various industries from energy production to medicine and computing. The unique properties of nanomaterials at the nanoscale enable the development of new materials, devices, and systems with improved performance and functionality. However, the potential benefits of nanotechnology come with some challenges, safety concerns, ethical considerations, and regulatory frameworks. I will explain these aspects now in detail. The safety concerns, for example, uh, then when we use the nanomaterial or nanocomposites, they have the way to get easily mingled with the flow of water or the soil or gas or the atmospheric air and so on. So these nanoparticles, in due course of time, uh, the world is afraid that one time we may have artificially created the existence of artificially created nanoparticles in the air to a maximum extent, which may pose a danger to the environment, not immediately but in future. Okay, next ethical consideration. So because nanoparticles or nanocomposites are not detectable, uh, ethical side can be used to very much for war purposes or for any other destructive purposes, or they can give, they can induce various types of diseases in the mankind without any notice, and maybe after some years we will notice the diseases which have been arised due to the nanoparticles. So that is why strict ethical consideration has to have to be followed, either whether it is laboratory environment or industrial environment or natural environment. People have to wear masks, gloves, and so on. So many other aspects. We cannot throw the nano waste as ordinary waste. So that is another danger. So, if you go to the advanced laboratories in India or US or Europe, they have the nano waste product dustbin box separately, and it is highly risky to suppose people without knowing that if they throw the nano powders or the nanoparticles in the ordinary dustbin box, definitely it will pose a great danger in the near future to the humankind as well as all other species in the world. So these are all to be considered the ethical guidelines. Nrucha. Yeah, Nrucha. It is actually.
Thank you very much, sir. Thank you for your brief and very interesting presentation. Thanks a lot, sir. Thank you very much. I would like to request all the participants to kindly, sir, kindly unshare your presentation, please. I would like to request all the participants to kindly switch on your video and switch off your mic so that we can take few photographs for this purpose.
Stop.
No, sir. Give me 2 minutes. Meeting and
I could mute them. I can't let that.
Santosh ji, done? Sorry, Ronak ji, done? Okay, thank you. I would like to thank all the participants, our honorable guest and the speaker, Dr. And I wish you all a very happy and the prosperous new year 2025 to you, your family, friends, and all staff. Thank you very much. Thank you all. Thanks a lot. We will meet next week with the next topic. Thank you, sir. Thank you. Thank you very much.
Thanks, sir. Thank you.
Thank you.
You'll get the certificate, right?
Thank you, sir.
meeting and
सर्टिफिकेट हम लोग को सर्टिफिकेट तो मिल जाएगी ना सर शेष है सर्टिफिकेट इस सेशन का सर्टिफिकेट कब मिलेगा किसी को पता है क्या
अभी तो नहीं पता